Hello friends, I welcome you in lecture number 12 on normal distribution. In this lecture, we will discuss this question on normal distribution which was asked in GTU Summer 2020 exam. First, we understand what is given in this question and what we have to find. Assume that 5% of the apples weigh less than 150 gram and 20% of the apples weigh more than 225 gram. If the distribution of the weight of the apples is normal, find the mean and standard deviation of the distribution. So here it is clear that this is the question of normal distribution because they have specified that the distribution of the weight of apples is normal and they have not given mean and standard deviation of the distribution. Instead of that, they have given that 5% of the apples are having weight less than 150 gram and 20% of the apples are having weight more than 225 grams. So using this information, we have to decide the mean and standard deviation of the normal distribution. So first we start by considering the notation capital X, which is a random variable, and here capital X is weight of the apples or weight of the apple, and it is given that X is a normal random variable. Given that capital X follows normal distribution with mean mu and variance sigma square or standard deviation sigma square, but we are not given values of mu and sigma. What is another information? It is assumed that 5% of the apples are having weight less than 150 grams. So that means the probability that capital X is less than, that is weight of the apple is less than 150 gram is 5%, that is 0.05, and the weight of the apple is more than 225 gram, that probability is 20%, that is 0.20. Probability that weight of the apples is more than 225 grams is 20%, that is 0.20. So using these probabilities, we have to decide mean, mu and variance or standard deviation of given normal random variable. So we start with this probability that capital X less than 150 is 0.05, and we standardize this random variable capital X. We subtract mean mu and divide by standard deviation, assuming that standard deviation is non-zero. Here also 150 minus mu divided by sigma, this is equal to 0.05. We are rewriting this event capital X less than 150 by taking subtraction of mean and division by standard deviation. So these two events are same. Therefore, probability that now this X minus mu over sigma is a standard normal random variable which we denote by capital Z. This is less than 150 minus mu divided by standard deviation. This is equal to 0.05. So here we are having this probability equal to 0.05, where capital Z is a standard normal random variable, and we know that this is cumulative probability. We have this type of situation here, probability that standard normal random variable is less than some value Z equal to 0.05, or we can say that area to the left of this point under standard normal curve is 0.05. We have this type of situation here. Suppose this point is Z, then area to the left of this point is, this area is 0.05, and we don't know what is this point. So we are given the area to the left of point Z, which is unknown, and using this area we have to find out the value of Z, for which this area is 0.05. So for that we will use cumulative standard normal table. In cumulative standard normal table we are given this type of probabilities. Probability that capital Z is less than or equal to Z, or areas to the left of this point Z. Here we are given the area to the left of this point 150 minus mu over sigma. We are having probability that capital Z is less than 150 minus mu over sigma is 0.05. We are given the value of area which is to the left of this point. So we have to decide the value of Z corresponding to this area 0.05, and in this table we are having all these values are areas to the left of this point Z, or probabilities that capital Z is less than or equal to Z. Therefore, to decide this value we have to search for 0.05 area in this table. So now we are searching for 0.05 value in this table. You can see all these are near to 0.05, and we have to find out the value which is closest to the 0.05 area. So we have these two values, 0.0505 and 0.0495. The difference of these two areas from required area 0.05 is same. So what we can do is we can take the average of Z values corresponding to these two areas. Here we have minus 1.6 corresponding to this row, and we have to search for this column and this column. So we have 0.04 and 0.05, and here I have minus 1.6. So the value corresponding to this 0.0505 is minus 1.6 plus 0.04, that is minus 1.64, and the value corresponding to this 0.0495 is minus 1.65. So the corresponding Z value will be taken as average of these two values, and average becomes minus 1.645. So if we consider small z equal to minus 1.645, then we can say that probability that capital Z is less than minus 1.645 is equal to 0.05. So now we can compare. Therefore we can see that this value must be equal to minus 1.645. We are interested in the value of Z such that probability that Z is less than this value is 0.05, and from the table we find that probability that capital Z is less than minus 1.645 is equal to 0.05. Therefore this value 150 minus mu over sigma is equal to minus 1.645. So that we write here. Therefore 150 minus mu over sigma, which is standard deviation, equal to minus 1.645, and in the bracket we can mention that from the normal table we have used statistical table for normal distribution. We find that probability that capital Z is less than minus 1.645 is 0.05. Therefore, we consider this point equal to minus 1.645, and this I can rewrite as 150 minus mu equal to minus 1.645 times standard deviation sigma, and I will give this as equation number 1. And now we are using this probability, and using this probability we will find out another equation in terms of mu and sigma, and solving those two equations we will decide mean and standard deviation of the normal distribution. Now second probability is that probability that capital X is greater than 225 is 0.20. Probability that X is greater than 225 is 0.20, and we are interested in the less than type probabilities. So from this we can decide that if this is, we are interested in this probability that capital X is less than or equal to 225, then using the definition of complementary events we can write this probability as 1 minus probability that capital X is greater than 225, and this is nothing but 0.20. 1 minus 0.20 is 0.80. So what we obtain? We have obtained probability that capital X is less than or equal to 225 is 0.20. Now we standardize this random variable capital X. So we subtract mean mu and divide by standard deviation sigma on both sides of this inequality. 225 minus mu over sigma, this is equal to 0.80. Therefore, probability that capital Z is less than or equal to 225 minus mean divided by standard deviation equal to 0.80. So again we have to use cumulative standard normal table. We have to search for 0.80 area, and using that value of area in the table we will be able to decide the value of Z for which this probability is 0.80. So here now I have to search for 0.80 in this table. So 0.80 should be somewhere here. This is 0.8078, this is 0.8023, 0.8051 is not near to the 0.80 as compared to this one, and if we consider this one 0.7995, and if we round off up to 2 decimal places, then we will have 0.80. So this value is closest value to 0.80 as compared to remaining values. Therefore we will consider this value to find out the corresponding value of Z, and this row corresponds to Z equal to 0.8, this corresponds to 0.04. So I have to take addition of 0.8 and 0.04, and I obtain that probability that Z is less than or equal to 0.84 is equal to 0.7995, and if we round off up to 2 decimal places it is 0.80. So this is our value 0.84. This value is 0.84. We obtain from the table that probability that Z is less than or equal to 0.84 is approximately 0.80, okay, using standard normal table. So because we have 0.84 corresponding to 0.80 area, Therefore, we can write that 225 minus mu over sigma is 0.84, and this I can rewrite as 225 minus mu equal to 0.84 sigma, and I will give this number 2. Now we are interested in the values of mean and standard deviation. So now we can solve equations 1 and 2 for mu and sigma, and we can see on the right hand side we have this standard deviation sigma, and we assume that sigma is positive. So we can consider division of equation 1 and 2, or we divide equation 1 by equation 2. So first we have to write down division of left hand sides. Here left hand side is 150 minus mu, here 225 minus mu. So 150 minus mu divided by 225 minus mu, this is equal to, on the right hand side we have sigma in the product, sigma will cancel out, and here I have minus 1.645 divided by 0.84, and if I take this division, this is going to be minus 1.9583. Therefore, I can write 150 minus mu equal to minus 1.9583 multiplied by this quantity 225 minus mu. Therefore, 150 minus mu, this is going to be this quantity into 225. So we have negative 440.625 minus minus plus and 1.9583 mu. Therefore 150, and we transfer this on this side, plus 440.625 equal to this plus mu, that is going to be 2.9583 mu. Therefore this 2.9583 times mean equal to addition of these two, which turns out to be 590.625. Therefore mean mu is division of 590.625 and 2.9583, and I obtain mean equal to 199.6501. Using my scientific calculator, I have made all these calculations by fixing calculator up to 4 decimal places. This is the value of mean for given normal distribution. Now we can substitute value of mean in either of these two equations, and we can find out standard deviation sigma. So from equation 2 we can see that standard deviation sigma is 225 minus mean divided by 0.84. So now we try to find out sigma. We can write that by equation number 2, standard deviation equal to 225 minus mean divided by 0.84. We have obtained the value of mean, which is 199.6501 divided by 0.84, and if I use my scientific calculator to find out this difference and divided by 0.84, I obtain the standard deviation as 30.1784. This is the standard deviation of given normal distribution. So in this way you can use given probabilities to decide the mean and standard deviation of the normal distribution. In earlier lectures what we have seen is the problems have mean and standard deviation given, and we are using that mean and standard deviation to determine the given probabilities. But here the situation is different. Here we are given two probabilities related to normal random variable, and using these two probabilities we have to decide the mean and standard deviation of the normal distribution. And for that we have taken use of cumulative standard normal table. We are given the areas to the left of this point, and we have to search in the table that for which value of z this area is 0.05, and similarly for which value of z this probability or this area to the left of this point is 0.80. And then we will obtain two equations in two unknowns mu and sigma, and solving these two equations we can easily find out mean and standard deviation. Okay, fine. So this is all about this question or this lecture. I hope you like it. Thanks for watching.